Hi there, everybody. I decided to put a video up on the introduction of atoms, even though we went over in class. I know there's some people that struggled with some of the material, and there were some people that missed the days when we went over this. So this is for you guys. Introduction to atoms. Let's get started. Atomic composition. We do know that atoms are really, really small, and they're made up of three main subatomic particles. Just in case you don't know what a subatomic particle is, it's the particles that make up an atom. You will need to know that term. Subatomic particle is a particle that makes up the atom. Sub meaning below. All right, first one, protons. Protons have a positive charge, hence the P with a plus sign, and here plus electrical charge, meaning positive electrical charge. The mass in the SI units is 1.672623 times 10 to the negative 24th grams. I do not expect you guys to know that. That's just to show you that it's really, really small. Since it's so small, having to write this many, many times if you were a scientist studying parts of the atom, they decided to not do that and came up with a relative mass. They came up with what's known as the AMU, atomic mass unit, and a proton has 1.007 atomic mass units, AMU. For what we're doing in class, we are going to round that to 1. Next up is the electron. You'll see the abbreviation as E with a negative sign. It has a negative electrical charge, hence the negative sign. And its relative mass in AMUs is 0.0005, but because that's so much smaller than 1.007, we just round it to 0 for what we're doing. The final subatomic particle we will be talking about is neutrons. They do not have a charge, hence the n to the 0 power. The mass of a neutron is relatively similar to the mass of a proton. It's a little bit higher, 1.009 AMU, but like we did in the other two, we're going round to 1. So if you have a proton, it has 1 AMU, electron, no AMUs, neutron, 1 AMU. Atomic number. All atoms of the same element have the same number of protons in the nucleus. The atomic number is that number of protons. If you look at a periodic table, the atomic number is typically on the top. I think on the yellow one that I gave you, it's on the top here. On one that I had in this presentation, a couple slides after this, it is off to, I believe, the left-hand side. Again, as I said, the atomic number is typically going to be on the top. It might be on one side or the other or in the center. If you aren't sure, most periodic tables have a key, so you check with the key. So if you were looking at a block from the periodic table, you have atomic number here, atom symbol here, and average atomic mass on the bottom. We'll be going over average atomic mass later. I'm not going to describe that just yet. Okay, so atomic number is the number of protons. Same thing, atomic number, number of protons. Atomic number, number of protons. Atomic number, number of protons. I said that so many times because I really, really need you to know that. Mass number. Carbon was used to figure out what the mass number was. They knew carbon had 6 protons and 6 neutrons, so it became the standard. Based on that, it has 12 atomic mass units, and that's how they came up with the calculation for mass numbers. Mass numbers are the sum of the number of protons and the number of neutrons. It's actually the sum of the number of protons, neutrons, and electrons that make up an atom, but since electrons are considered to have 0 AMUs, you don't have to count them. So it's just number of protons plus number of neutrons. The mass of the atom based on how many things it's made up of. So if you have an atomic number, you know the number of protons. You may not know the number of neutrons, but you're more than likely to be given the mass number, and I'll get to why that's important in a second. You're not going to be able to find the mass number on the periodic table because the periodic table shows the average atomic mass. I just mentioned it in the slide before, and as I said, I'm going to get to that later. Boron on the periodic table has an average atomic mass of 10.811. If we're talking about one specific boron atom, we write it differently. We write it like this, the worksheet and scientist way of writing it. So the boron atom I'm talking about is this one right here. B for boron. Its mass number is 10 because it has 5 green for protons and 5 red for neutrons. That comes out to 10. The atomic number is 5 because, as I said, there are 5 green which was protons. 5 protons, atomic number is 5. Mass number is 10 because protons plus neutrons equals the mass number. I know, it's repetitive, but I think it just needs to sink in that way. Okay, so here is a little learning check. Carbon consists of 3 isotopes. I'll explain what that is next. But here's 3 different types of carbon. Carbon with a mass number of 12. That's the first one here. Carbon with a mass number of 13, and carbon with a mass number of 14. This is the worksheet scientist way of writing these, as you can see right here. So this is carbon 12, carbon 13, carbon 14. These are the atomic numbers on the bottom, mass numbers on the top. Based on that, take a second, write the number of protons, neutrons, and electrons for each of these atoms. Yes, I am waiting. All right, now I'm going to go on to the next slide, which shows the answers. If you're not ready, pause it for a second. All right, here are the answers. As you can see, each one of them has the same number of protons. Why is that? The number of protons determines what element it is. Since they are all carbon, they all have to have the same number of protons. If the number of protons changes, the element changes. So, 6 for the atomic number, 6 for the number of protons. Since there is no charge here, these are just regular atoms of carbon, uncharged atoms of carbon, the number of electrons will equal the number of protons. That's why you have 6, 6, and 6 down here. Now, if you look at the number of neutrons, that's where it's different. The number of neutrons is going to be equal to the mass number minus the atomic number. So 12 minus 6 equals 6. Why is it that? Because when you figure out the mass number, it is the number of neutrons plus the number of protons. And since the atomic number is the same as the number of protons, then all you have to do is take the mass number, subtract the number of protons or the atomic number. That gives you what's left in the mass number, or calculating the mass number, which is the number of neutrons. So if the mass number is 13 and you already have 6 protons, to figure out how many neutrons, 13 minus 6 gives you 7. And lastly, 14 minus 6 gives you 8. Okay, moving on. This was a do now we did in class. What is the atomic number of titanium? How many protons does it have? How many electrons does it have? How many neutrons does it have? It's a regular atom, so that means the number of electrons equals the number of protons. So if you want to try this one, pause it, and I will give you the answers once you come back. I'm assuming you have now come back, so atomic number is here, titanium, which is 22. So it has 22 protons. It's a regular atom, meaning it doesn't have a charge, so it has 22 electrons. And how many neutrons does it have? You take the average atomic mass, round it to the ones place. That'll give you 48, and that's what we're going to use as the mass number. 48 minus 22 gives you 26. Okay, let's move on. Isotopes. Now I mentioned that just before when we were going over the carbon on the learning check. All of those carbons, those 3 different carbons, were isotopes of each other. Isotopes are atoms of the same element, meaning they have the same atomic number, but they have different mass numbers. So when you have isotopes, or different versions of the same element, the thing that is different about them is the number of neutrons. They have to have the same number of protons, but they have a different number of neutrons, and because of that, they have different mass numbers. As we can see here with boron. Boron 10 has 5 protons, like boron's supposed to have because that's its atomic number, but it has 5 neutrons. Boron 11, still boron, so it still has 5 protons. In this case, it has 6 neutrons, because 5 plus 6 equals 11. Different versions of the same element. Okay, let's move on. So this is a picture of 2 isotopes of sodium. It's really hard to see because the nucleus is made up of light blue and gray, but if you were to count them and get them real close, you would see that there's 11 protons and 13 neutrons, or 11 of one color and 13 of the other. To be honest, I can't even see the difference right now. Okay, so now we're going to talk about isotopes. Looking at these 4 different things right here, I would like you to tell me which of the following represent isotopes of the same element, and then looking at a periodic table, you should be able to figure out what element the isotopes are. In these examples, like we showed before with the worksheet and scientist writing way, the atomic number is on the bottom, and mass number, it says atomic mass, sorry, mass number is on the top. Okay? So take a second, pause it, and try and figure out which ones are isotopes of the same element. All right, I'm assuming you're back now, and we'll go over which ones they are. So the ones that are isotopes are the first, the third, and the fourth. Reason being is because they are the same atomic number. So they have the same atomic number, meaning they have the same number of protons, meaning they are the same element. The thing that is different is the mass number. 234, 235, and 238. They have the same number of same number of protons, same atomic number, but the thing that's going to change up here is the number of neutrons. Well, because of what's up here, the number of neutrons change. Okay? And this element, if you were to look at the periodic table, so if I go to periodic table, which I'm going to right now and bring that up for you. Oops. Number 92 is not visible. Hold 1 second. Make it a little bit smaller and hopefully, there we go. Number 92 is right here and is uranium. And as you can see, its average atomic mass is 238. So that means that we have a lot of the isotope uranium-238. As I said, average atomic mass, I'll be getting to it. Just wait. Okay, back to the presentation. Okay, moving on. Learning check. An atom has 14 protons and 20 neutrons. I'm just going to let you guys check this out on your own. Pause it, give it a shot, and I'll show you the answers when you get back. Okay, 14 protons, 20 neutrons. The answer is 14. The mass number is 34. 14 plus 20, 34. The element is silicon. The atomic number is the same as the number of protons, and the element with 14 for the atomic number is silicon. Another isotope of this element would be 3. It has the same number of protons as the one that was talked about up here, but it has a different mass number than the one that was talked about up here. So these two are both isotopes of silicon, but this is another isotope. It's the one that wasn't talked about before. Okay? Moving on. Ions. Ions are atoms or groups of atoms with a positive or negative charge. Also, I'll call them charged particles in class. The positively charged ion is a cation, and this is formed when electrons are taken away. You can't add protons. If you add protons, you change the element. So you can only take away electrons. Protons will stay the same. You can take away electrons, and that's what makes it positive. If you were to add electrons, it would become negative, and then you have what's known as an anion. Okay? If you are looking at different elements written down, and you see pluses, or plus with a number, or minuses, and minuses with a number, these are atoms. So if it's just a plus, that's an understood 1 afterwards, so it's +1. If it's just a minus, it's a -1. Just in case you didn't know, this is an I for iodine, and this is an O for oxygen. It's not 1 and 0. These are the ions, these are the atoms. Okay, forming cations and anions, like I said before, cations lose electrons, anions gain electrons. And generally speaking, metals will be the ones that lose electrons to make cations, and non-metals will gain electrons to form anions. All right, let's move on. This is just a summary page. I'm not going to talk it over because this is all stuff that if you want to copy it down, feel free. That is all we've gone over so far in class. So I will do another video with average atomic mass after we go over Bohr model. Okay, so that is it. I know it's long, but I really need you to know this well. Okay, take care, guys.